evaluating functions with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. A function is a mathematical rule that takes an input, usually denoted as x, and produces an output which is usually denoted as f of x. It is often written as f of x is equal to some type of expression, which in this case is 7x take away 8, and the expression defines how the input of x is transformed into an output. So here the function takes x, which is the input, multiplies it by 7, and then subtracts 8. Evaluating a function means finding the output of the function for a specific input value of x. To evaluate, we substitute the given value of x into the function and we simplify. For example, if we're finding f of 2, we substitute into the expression 7 lots of 2, subtract 8 is the same as 14, subtract 8, and this simplifies to give me a final answer of 6. On to the second question. I'm finding f of 8, replacing x for 8. 7 lots of 8 is 56, and subtracting 8 will give me 48. For the last question, this is where it gets a little bit trickier, substituting negative values. 7 lots of negative 8 is negative 56, and subtracting 8 is negative 64. On to the advanced questions with an increase in difficulty. Here we can see f of x is equal to a slightly more complicated expression involving powers or indices, 3x squared plus 2. The idea is still the same. To evaluate f of 4, I'll need to replace x or substitute x with 4. 3 lots of 4 squared plus 2. Here we have multiple operations, so we'll need to consider order of operations, BIDMAS. Indices comes first, so we'll need to do 3 lots of 4 squared, which is 16. And then I can add 2. 3 lots of 16 is 48, plus 2 gives me 50. For the next part of the question, again, taking care when substituting negatives and always use brackets in replace of x. 3 lots of negative 3 squared plus 2. Again, I'll need to use BIDMAS to complete negative 3 squared first. And multiplying a negative by a negative will give me a positive. So in this case, positive 9. I need to multiply this by 3 before adding 2. 3 times 9 is 27, and adding 2 gives me 29. For the second question, we have f of x is equal to an even more complicated expression, 2x squared minus 3x take away 1. We're substituting, replacing x for 3, 2 lots of 3 squared minus 3 lots of 3, subtract 1. Focus on simplifying each term individually. 2 lots of 3 squared is 2 lots of 9. I'm taking away 3 lots of 3, which is 9, before subtracting 1. My final answer, 2 lots of 9 is 18, take away 9 is 9, and then subtracting 1 to give me my final answer of 8. For the second part of the question, I'm substituting replacing x for negative 2, which would be 2 lots of negative 2 squared minus 3 lots of negative 2 before subtracting 1. Simplifying the first term, 2 lots of negative 2 squared will give me positive 4, and then I'm subtracting 3 lots of negative 2. Subtracting a negative number is the same as adding, and in this case 3 times 2 is 6, before I subtract 1. 2 times 4 is 8, plus 6 is 14, take away 1 gives me my final answer of 13. On to the advanced questions, some of the trickiest questions that you're likely to find on this topic. Typically the notation used to represent functions is f of x, but we don't have to use the letter f. We can use any letter we like. In this case we have g of x. We tend to have a different letter used if there's a question that involves 2 different functions. They might label one as f of x and the other as g of x. G of x is equal to 5x plus 6. They want us to evaluate by writing an expression for g of 3x. This time, I don't have a numerical value that I'm substituting for x. I have another algebraic expression. So I'm still going to substitute and replace for x, but I'll be replacing it with 3x. And then I need to simplify my expression. 5 lots of 3x is 15x, and then adding 6. This can't be simplified any further, meaning that my final answer is 15x plus 6. For the second part of this question, notice that x is just being replaced with x, so that part will remain the same. But we have a 3 in front of the function, which means that we're multiplying the whole expression by 3. So I can start by putting 3, and the best thing to do is open up a bracket and place the whole expression 5x plus 6 inside the bracket. Expanding this bracket is no more simplified than having a factorised version, so you can leave your answer as 3 bracket 5x plus 6. Alternatively, if you did expand the bracket and had 15x plus 18, then that would be absolutely fine as well. For the second question, we're replacing x for x minus 1. Again, we'll want to use a bracket to replace x for x minus 1. Now I will need to expand these brackets, unlike the question before, since when I expand these I will be able to collect like terms, therefore it will be more simplified by expanding. First, I'll focus on x minus 1 squared. This will be a double bracket of x minus 1 multiplied by x minus 1. Expanding and simplifying x minus 1 squared is x squared minus 2x plus 1, and then I'm taking away 2x plus 2 if I expand the bracket. Expanding the first bracket gives me 3x squared minus 6x plus 3, and then I'm taking away 2x plus 2. I can simplify, collecting like terms. 3x squared shares no like terms, so will stay the same. Negative 6x will collect with negative 2x and give me negative 8x, and 3 plus 2 will simplify to give me positive 5, meaning my final answer is 3x squared minus 8x plus 5. On to the final question. I'm writing an expression for 2 lots of f of x, and then I'm subtracting 1 from the end. So 2 lots of, substitute the whole expression, 3x squared minus 2x in a bracket, and then at the end I was subtracting 1. Expanding this single bracket, 2 lots of 3x squared is 6x squared, and 2 lots of negative 2x is negative 4x. Before subtracting 1, we have no like terms for additional simplifying, so therefore my final answer is 6x squared minus 4x, take away 1. Here's a question that I've completed earlier. It appears as though I have made some mistakes, so pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.